studied average and instantaneous velocity. In previous lecture, we completed the formula or the equation for average velocity in two dimensions, and we get the formula for that, that is phi average. We can call as a phi average or average velocity. Vector phi average or average velocity in two dimensions. Therefore, which is equal to phi average along x-axis and its unit vector I cap, and plus phi average along y-axis and its unit vector j cap, where phi average x is equal to x2 minus x1 divided by t2 minus t1, and phi average along y-axis is equal to y2 minus y1 divided by t2 minus t1. This velocity phi average along y-axis, therefore y2 minus y1 divided by t2 minus t1. We know the formula for velocity is changing displacement along that axis. Along y-axis it is y2 minus y1. If changing displacement along x-axis, then it is x2 minus x1, and in this way we can find out the average velocity in x and y plane, that is x and y dimensions. And we in chapter number 2 we studied if there is a vector, we can find out its rectangular components, and by finding its rectangular components, we can find out its magnitude and direction also. So phi average x and phi average y is the rectangular components of average velocity. I repeat again, phi average x and phi average y is the rectangular component of average velocity. Therefore, we can find out or we can gauge the magnitude and direction of average velocity. So, if in terms of rectangular components, we write this equation as it is, and if we want to find out the magnitude of average velocity and direction, we get the equation phi is equal to square root of, how we get magnitude? In chapter number 2, we studied if this is the y-axis and this is the x-axis, and its resultant is r, then magnitude of r we can find out as rx square plus ry square, and its angle, that is tan theta is equal to ry divided by rx. Similarly, in case of velocity, we can find out its magnitude, and for the magnitude we get as a value px square, that means velocity along x-axis, px square plus py square. We get the magnitude of average velocity. And if we want to find out the direction of this average velocity, then tan theta is equal to py divided by px. Here we are talking or we are studying about velocity, therefore we are taken py divided by px. From this formula we get the direction of average velocity. So this is the magnitude and this is the direction of average velocity in two dimensions. So we get average velocity in two dimensions, and the next point is instantaneous velocity in two dimensions. So let's start with instantaneous velocity in two dimensions. We know the definition for instantaneous velocity. That means the velocity or changing displacement for a small interval of time. That velocity we call it as a instantaneous velocity. Now we are going to study in two dimensions. Therefore, this is x-axis and this is x-axis and this is y-axis. Suppose the particle or object is moving from point P to Q. From point P to Q. Now this distance, along y-axis there is the distance or displacement of particle, and along x-axis there is the time axis. So displacement of this particle is too small. In diagram it is about 1 centimeter, but it is less than 1 centimeter. That means it is too small displacement, and for that displacement the time required is from T1 to T2. From T1 to T2 for a small displacement. If there is a 1 centimeter object displaces from point P to Q and this total distance is 1 centimeter, for a point 1 displacement, we can find out its instantaneous velocity. Smallest point ला सुद्धा आपण त्याची काय फाइंड आउट करू शकतो, instantaneous velocity with respect to time फाइंड आउट करू शकतो. ठीक आहे. So from graph we can find out the equation for instantaneous velocity, same as average velocity, but there is little bit change in formula. For example, this is the displacement of particle, and there is a small change of displacement of particle from say P to Q. Here is the point P and here is the point Q. This is the small displacement, and this displacement we can find out using the tangent. Using a tangent along x-axis or along this tangent along this curve. So see, we take this as a rectangular or slope of the line, and this is the velocity along y-axis. Therefore I write here Vy, and this velocity is along x-axis. Therefore this distance is Vx. So the definition of instantaneous velocity is same as we already studied in a rectilinear motion. So definition is same, and using the definition we can write the velocity, formula for velocity, instantaneous velocity, vector phi. Now students, you have to remember, if velocity, it may be average or instantaneous. For average velocity we can write as a phi average, but for instantaneous velocity we generally use as a letter phi. Phi instantaneous velocity, phi is equal to, vector phi is equal to limitations of delta t tends to 0, delta x divided by delta t. Vector delta x divided by delta t, which is equal to dx divided by dt. Instantaneous velocity, limitations of delta t tends to 0, delta x, vector delta x divided by delta t, which is equal to dx divided by dt. We get the instantaneous velocity, general formula for instantaneous velocity. Now we have to express this velocity in two dimensions. We have to express this instantaneous velocity in two dimensions. So we can write this formula as dx divided by dt I cap plus dy divided by dt j cap. Instantaneous velocity is equal to dx divided by dt I cap plus dy by dt j cap. So we get the formula for instantaneous velocity in a two dimensions. टू डायमेन्शन्समध्ये आपल्याला अशा पद्धतीने instantaneous velocity साठी फॉर्म्युला मिळतो बिकॉज द ऑब्जेक्ट आर मूव्हिंग इन x अँड y डायमेन्शन्स. x अँड y डायमेन्शन्स मध्ये तो ऑब्जेक्ट मूव्ह होतोय म्हणून त्यासाठी फॉर अ शॉर्ट टाइम इंटरवल साठी आपल्याला इन्स्टंटेनियस फॉर्म्युला जो आहे तो x अँड y डायमेन्शन साठी कोऑर्डिनेट सिस्टीम साठी अशा पद्धतीने मिळतो. ठीक आहे. मग आपल्याला याची काय करायची आहे फाइंड आउट. वी हॅव टू फाइंड आउट मॅग्निट्यूड अँड डायरेक्शन. जी काही इन्स्टंटेनियस व्हेलॉसिटी आहे त्या इन्स्टंटेनियस व्हेलॉसिटीची मॅग्निट्यूड अँड डायरेक्शन फाइंड आउट करायची आहे ज्या पद्धतीने आपण ॲव्हरेज व्हेलॉसिटीची फाइंड आउट केलेली आहे. सो मॅग्निट्यूड ऑफ इन्स्टंटेनियस व्हेलॉसिटी वेक्टर v इज इक्वल टू स्क्वेअर रूट ऑफ मॅग्निट्यूड काढताना आपण स्क्वेअर रूट घेत असतो therefore स्क्वेअर रूट ऑफ dx स्क्वेअर डिवाइडेड बाय dt स्क्वेअर प्लस dy स्क्वेअर divided by dt square. This is the magnitude of instantaneous velocity, and if we want to find out the direction, of instantaneous velocity, then for direction we know the formula tan theta along y-axis. Slope of the line is y divided by x. Slope is equal to general formula for slope y divided by x. So tan theta is equal to dy by dt divided by dx divided by dt, which is equal to dt get cancelled. So we get the formula for direction as a dy divided by dx. Tan theta is equal to dy divided by dx, which is the slope of dy divided by dx. This is the slope of tangent to curve at a point at which we can calculate the instantaneous velocity. At this point, for a small displacement of the point, we can find out the instantaneous velocity, the magnitude and direction. So in two dimensions we get the formula and the magnitude and direction for average velocity. As for average velocity we get vx square plus vy square and direction is vy divided by vx. And for instantaneous velocity dx square by dt square plus dy square by dt square and direction is dy by dx. This is the average and instantaneous velocity in two dimensions. ठीक आहे. मग टू डायमेन्शन्समध्ये आपल्याला ॲव्हरेज आणि इन्स्टंटेनियस व्हेलॉसिटी हे चार इक्वेशन जे आहेत ते इक्वेशन्स मिळालेले आहेत. नंतरचा नेक्स्ट पॉईंट जो आहे तो आपण पाहणार आहोत दॅट इज ॲव्हरेज अँड इन्स्टंटेनियस ॲक्सेलरेशन इन टू डायमेन्शन्स. Average acceleration in two dimensions. Now students, definition is same as we see in rectilinear motion. Velocity acceleration आपण रेक्टिलिनियर मध्येही पाहिलं आणि आता आपण टू डायमेन्शन मध्येही स्टडी करतो. ठीक आहे. डेफिनेशन टू डायमेन्शन असेल किंवा रेक्टिलिनियर मोशन असेल डेफिनेशन जे आहे त्या डेफिनेशन सेम असतील. डेफिनेशनमध्ये काहीही चेंजेस नसणार आहे. मग ते ॲव्हरेज व्हेलॉसिटी असेल किंवा इन्स्टंटेनियस व्हेलॉसिटी असेल, इन रेक्टिलिनियर मोशनमध्ये असेल किंवा इन टू डायमेन्शन्स मोशनमध्ये असतील तर डेफिनेशन जे आहे त्या डेफिनेशन त्याच राहतील. डेफिनेशनमध्ये काहीही चेंजेस नसणार आहे. सो फर्स्ट वी फाइंड आउट द ॲव्हरेज ॲक्सेलरेशन युजिंग अ ग्राफ इन अ टू डायमेन्शन्स. सो ॲव्हरेज ॲक्सेलरेशन वी कॅन शो दॅट बाय ए ॲव्हरेज. ॲव्हरेज ॲक्सेलरेशन जे आहे ते आपण कसं दाखवतो की वेक्टर ए स्मॉल ए ॲक्सेलरेशनसाठी आपण स्मॉल ए लेटर यूज करतो. इट इज अ वेक्टर क्वांटिटी therefore वेक्टर ए ॲव्हरेज AV means average acceleration of a particle between the points T1 and T2 can be written as, जसं आपण ग्राफमध्ये दाखवलं होतं, average acceleration vector A average is equal to, now we know the formula for acceleration. Acceleration साठी formula काय आहे? A is equal to change in velocity divided by time. This is the general formula for acceleration. A is equal to change in velocity divided by time. Now A average is equal to change in velocity, that means v2 minus v1 divided by t2 minus t1. A average is equal to v2 minus v1 divided by t2 minus t1. Now we have to find out this acceleration in two dimensions. If we draw a graphical representation of this acceleration, along y-axis there is a change in velocity and along time axis there is a time. So velocity v divided by t we get as the acceleration, and the slope of the line is like this. So we have to calculate this displacement or the acceleration with respect to velocity and time axis. I repeat again, we have to calculate the acceleration of this object with respect to velocity and time axis. So we can write this average acceleration vector A average is equal to along x and y axis. X axis, that means along time axis, and y axis, that means along velocity axis. So we get the formula as v2 minus v1, therefore v2x minus v1x divided by t2 minus t1 along x axis, therefore I write here as a I cap, plus v2x minus v1x, that means this is the chain. For example, this is the first point x1 and this is the x2 point. Then along x axis v2x minus v1x divided by t2 minus t1 divided by t2 minus t1 plus in two dimensions, therefore we can write as v2y minus v1y divided by t2 minus t1 into j cap. Students, attention here, we are going to study the acceleration in two dimensions. We are going to study acceleration in two dimensions, therefore we write the acceleration in x-axis and in y-axis, x and y-axis. Therefore v2x minus v1x, changing velocity along x-axis. Therefore v2x minus v1x divided by t2 minus t1 into I cap, plus along y-axis again v2y minus v1y divided by t2 minus t1 into j cap. Therefore average acceleration average A average is equal to average acceleration average along x-axis, therefore I write here x, plus acceleration average along y-axis, that is A average along x-axis. We get the formula as v2x minus v1x divided by t2 minus t1 because the acceleration along x-axis. Similarly, A average along y-axis, we get the formula as v2y minus v1y divided by t2 minus t1 divided by t2 minus t1. आता पहा या फॉर्म्युलामध्ये मी काय लिहिलेले आहे vx and v1, vx, but v2x, that means the final point or final velocity of that object, therefore I write here v2 minus v1, that means initial point, that means initial velocity along x-axis, and changing velocity we get average velocity. How we find out change? That is difference between 2 points, difference between the 2 points in velocity. Therefore v2x minus v1x divided by t2 minus t1 into r cap plus along y-axis similarly v2y minus v1y divided by t2 minus t1 into j cap. And this formula we can write as in a 2 dimensions average vector A average is equal to A average along x axis plus A average along y axis. Now we have to find out the magnitude of this acceleration, average acceleration. जसं आपण अगोदरच्या केसेस मध्ये वेलोसिटी ॲव्हरेज व्हेलोसिटीला मॅग्निट्यूड फाइंड आउट केली होती, त्याच पद्धतीने आपल्याला ॲव्हरेज ॲक्सेलरेशनला त्याची मॅग्निट्यूड जी आहे ती मॅग्निट्यूड 2 कोऑर्डिनेट सिस्टीम मध्ये फाइंड आउट करायची आहे. आणि त्यासाठी फॉर्म्युला जो आहे तो फॉर्म्युला आपल्याला काय मिळतोय तर formula for magnitude of average velocity vector A is equal to square root of A average along x axis plus A average along y axis, A average square along x axis plus A average along y axis square, and from this formula we get the magnitude of average acceleration. Similarly, if we want to find out the direction, and we know that direction can be find out by the tan theta. Tan theta ने आपण त्या acceleration ची direction जी आहे ती direction find out करतोय. Therefore, A average along y axis divided by A average along x axis. In this way, we can find out magnitude of average acceleration in 2 dimensions, and the direction is A average y divided by A average x. So we get the average acceleration in 2 dimensions. या पद्धतीने आपल्याला average acceleration मिळते. आता नेक्स्ट पॉइंट जो आहे that is instantaneous acceleration in 2 dimensions. So next point is instantaneous acceleration. Instantaneous acceleration. The definition is same as that of average or instantaneous acceleration. Change in acceleration with respect to small interval of time is called as a instantaneous acceleration. Now we have to find out instantaneous acceleration in 2 dimensions, and for that we know the general formula for acceleration. Vector A is equal to change in velocity. Change in velocity, that means we have to write as v2 minus v1 divided by t2 minus t1. But we have to find out the formula for instantaneous acceleration. Therefore, this formula we can write as acceleration vector acceleration is equal to limitations of t tends to 0. Limitations of t tends to 0. That means for a small interval of a time. Therefore, limitations of here is delta t tends to 0. Change in velocity we can write as a delta v, vector delta v divided by delta t. Change in velocity, that means delta v. For a change we can write as a symbol delta. This triangle we call it as a delta. Delta v, vector delta v divided by delta t. So we get the formula for instantaneous acceleration. हा फॉर्म्युला जो आहे तो आपल्याला कशासाठी मिळालेला आहे तर इन्स्टंटेनियस ॲक्सेलरेशन साठी मिळालेला आहे. ठीक आहे, पण आपण स्टडी कशामध्ये करतोय आपण स्टडी जो आहे तो 2 डायमेन्शन मध्ये करतो. दॅट मीन्स द मोशन ऑफ अन ऑब्जेक्ट इन एक्स अँड वाय कोऑर्डिनेट सिस्टीम 2 डायमेन्शन मध्ये स्टडी करतोय. त्यामुळे हा जो काही फॉर्म्युला आहे तो आपल्याला कशामध्ये लिहायचा आहे, 2 डायमेन्शन्स मध्ये लिहायचा आहे. Therefore this formula becomes as a limitations of delta t tends to 0, limitations of delta t tends to 0 in bracket dvx divided by dt into I cap plus dvy divided by dt into j cap. ठीक है, dvx divided by dt I cap plus dvy by dt into j cap, which is equal to this formula we can rearrange like this. We know that px, we know that px. Now here is one point, there is one limitations. इथे limitations येणार नाही कारण आपण dvx लिहिलेलं आहे. That is delta v by delta t. We can write as a dv by dt. The limitations of delta t tends to 0. Vector delta v divided by delta t. This total formula we can write as dv divided by dt. dv divided by dt, that is small change in velocity with respect to time. Therefore here इथे जे आहे ते इथे limitations येणार नाहीये. फक्त dv by dt हा instantaneous acceleration साठी जनरल फॉर्म्युला झाला. तो आपण 2 डायमेन्शन्स मध्ये कसा लिहिलेला आहे, dvx divided by dt I cap plus dvy by dt into j cap. Now we know that px, we know that px, that means px is equal to change in displacement. Px means change in velocity along x-axis, and for this px we get the formula as a dx divided by dt. We know that change in displacement with respect to time is velocity. Change in displacement with respect to time is velocity. But this change is along x-axis, therefore we write as a px, and py is equal to dy by dt. Py is dy by dt. That means change in velocity along y-axis. Change in velocity along y-axis. Therefore we write as a py is equal to dy divided by dt. Change in displacement along y-axis. Therefore substitute these values in this formula, we get as a instantaneous acceleration is d by dt, take outside, d by dt take outside, and px we can write as dx by dt. px by तो आपण अशा पद्धतीने लिहू शकतो dx by dt plus into I cap plus d by dt and py ची व्हॅल्यू आपल्याला मिळालेली आहे, that is dy by dt into j cap, dy by dt into j cap. So we get the instantaneous acceleration in a 2 dimensions. Vector a is equal to d by dt into dx by dt. That means d square x by dt square x divided by dt square into I cap plus dy square d square by divided by dt square into j cap. This is the formula for instantaneous acceleration. हा जो फॉर्म्युला आहे तो आपल्याला कशासाठी मिळतोय, तर instantaneous acceleration साठी मिळतोय in a 2 dimensions. 2 डायमेन्शन्स मध्ये आपल्याला हा फॉर्म्युला जो आहे तो फॉर्म्युला मिळतोय, आणि हा फॉर्म्युला मिळाल्यानंतर आपल्याला त्याची मॅग्निट्यूड जी आहे ती मॅग्निट्यूड फाइंड आउट करता येते. आणि मॅग्निट्यूड फाइंड आउट करताना फॉर एक्झाम्पल d स्क्वेअर x डिवाइडेड बाय dt स्क्वेअर, त्याच्यासाठी आपण ax acceleration along x-axis use करू शकतो. Therefore, I write here ax is equal to d square x divided by dt square, and for d square y we can write as a ay is equal to d square y divided by dt square. Therefore, instantaneous acceleration vector A is equal to ax I cap plus ay j cap. Vector A is equal to ax I cap plus ay j cap. This is the formula, or this is the equation for instantaneous acceleration in two-dimension system. Instantaneous acceleration in two-dimension x and y dimension system, and from this equation we can find out magnitude and direction for instantaneous acceleration. For a magnitude we can write as vector A is equal to square root of ax square plus ay square, plus ay square, and its direction is tan theta. Tan theta is equal to ay divided by ax. That means d square x divided by dy square. D square x divided by dy square y, because dt and dt get cancelled. So we get this formula for direction of acceleration. This formula we get direction for instantaneous acceleration, and from this formula vector A is equal to square root of ax square plus ay square. From this formula we get the magnitude of instantaneous acceleration. So acceleration in two dimensions, we study average acceleration. Average acceleration we find out in two dimensions. For a magnitude we get average acceleration is equal to square root of a average square x plus a average square y. That means from this formula we get magnitude of average acceleration, and for direction we use tan theta, a average y divided by a average x. Similarly, for an instantaneous acceleration, that means for a short time interval there is a change in acceleration, and we get the magnitude as vector A is equal to ax I cap plus ay j cap. We get the magnitude of instantaneous acceleration, and for direction we get the formula tan theta is equal to ay divided by ax. So in this way we can find out the equations for average acceleration and instantaneous acceleration in two dimensions. So this up to this point our average and instantaneous acceleration velocity in two dimensions, this point is complete, and the next point is equation of motion of an object traveling in a plane with uniform acceleration. So next, equation of motion for an object. Equation of motion, I write here equation of motion. Motion for an object traveling a plane with uniform acceleration. Traveling a plane with uniform acceleration. uniform acceleration. We find out the equation of motion in a rectilinear topic or rectilinear point. For that we get three equations of motion. First equation is phi is equal to u plus at. Second equation of motion is s is equal to ut plus 1 half at square, and third equation is twice as is equal to v square minus u square. This equation we call it as a equation of motion. Now we have to find out this equation, or we have to represent this equation in uniform motion or equation of a motion for an object traveling in a plane with a uniform acceleration. So for that we know that u is the initial velocity of object. U is the initial velocity of object. I write here initial velocity of object at t is equal to 0, and v is the final velocity. V is the final velocity of object. At t is equal to at time t. Final velocity of object at time t. So as the acceleration is constant, because it is uniform acceleration. Acceleration is constant. Acceleration is constant. Acceleration is constant because object traveling in a plane with uniform acceleration. That means changing velocity with respect to time in equal intervals. Therefore we get the constant acceleration, and for that constant acceleration the average acceleration the average acceleration and instantaneous acceleration will be equal. Acceleration जे आहे ते average असेल किंवा instantaneous असेल ते कॉन्स्टंट ॲक्सेलरेशन मध्ये त्याची किंवा युनिफॉर्म ॲक्सेलरेशन मध्ये दोघांची व्हॅल्यू जी आहे ती आपल्याला काय मिळते, सेम मिळते. ॲव्हरेज असेल किंवा इन्स्टंटेनियस असेल. देन बाय डेफिनेशन वी नो द डेफिनेशन ऑफ ॲक्सेलरेशन, that is changing velocity with respect to time. Changing velocity, vector A is equal to changing velocity, final velocity is v, therefore vector v minus vector u, initial velocity is u, divided by time interval, that means t minus 0. Initial time जो आहे तो काय आहे, तो तुमचा 0 आहे. therefore we get vector A is equal to vector v minus vector u divided by t, and from this we get the first equation of motion, v is equal to u plus at. We get first equation of motion, that is vector v is equal to vector u plus at in a vector form for a constant acceleration. So for a constant acceleration we get the A is equal to vector u plus vector v divided by 2. For a constant acceleration or v average here, v average is equal to vector u plus vector v divided by 2. So displacement, we know the formula for velocity. V is equal to vector v is equal to vector s divided by t, displacement divided by time. Therefore vector s is equal to vector v into t. Therefore we get the formula as vector u plus v divided by 2 plus u plus v. Vector u plus vector v. So vector u plus vector v divided by 2 plus at, because this time t we can write as at divided by 2 divided into t. Therefore, we get the equation as a vector s is equal to ut. Vector s is equal to ut plus 1/2 at square. We can write this as a ut plus 1/2 at square, and this is the second equation of motion. So s is equal to ut 1/2 at square. This is the second equation of motion, and up to this point we take the first equation of motion, and this is the second equation of motion in 2 dimensions. So up to this point today we stop here. Thank you.